Welcome! In this explainer, we are going to crack the code on C programming's operators and expressions. We're going to focus specifically on those tricky, confusing questions that always seem to pop up in exams.
Okay, let's dive right in with a classic trick question. Most developers actually get this wrong on their first try, but trust me, by the end of this, you'll know exactly why it works the way it does.
To solve puzzles like that, we first need to understand the rules of the game. Think of it like a battle of operations. First, there's operator precedence, which is like a ranking system that decides which operation goes first. And then there's associativity, the tiebreaker rule for when operators have the same rank.
Let's start with a really fundamental challenge. When you look at this expression, what do you think the computer does first, the addition or the multiplication? Well, in C, multiplication has a higher precedence than addition. What that means is the compiler always calculates the 6 times 2 part first, almost as if it had parentheses around it from the start. And here you can see that step-by-step evaluation. After the multiplication is done, we're left with a simple addition, which brilliantly illustrates how we get to our final answer of 17. Okay, but what happens when operators have the same level of precedence, like in this expression? This is where that tiebreaker rule we talked about, associativity, comes into play. Most operators in C, and that includes subtraction, are left-to-right associative. That just means the computer works its way from left to right. It does 5 minus 3 first, which gives it 2, and then it takes that result and does 2 minus 2, leaving us with a final answer of 0. All right, let's move on to logical operators. This is an area where things aren't always what they seem, thanks to a clever efficiency trick that C uses.
This brings us to a really interesting concept called short-circuiting. Looking at this if statement, the real question is this: does that B++ part ever actually run? The logical AND operator is designed for efficiency. If the first part of the expression is false, and here A is 0, which means false, it already knows the entire expression has to be false. It doesn't waste time evaluating the second part. This short circuit means the B++ is completely skipped over. And that brings us to one of the most common points of confusion for new C programmers: that subtle but powerful difference between putting the increment and decrement operators before or after a variable. As you can see, the placement of that ++ completely changes when the variable's value gets updated. It's a tiny syntactical detail with huge consequences. Let's see this in action.
Here, we're using the postfix version. Now remember the rule: use the current value first, then increment. So what happens is the original value of A, which is 5, is used first in the expression. Only after that value is used does the variable get updated to 6 in memory.
Now we've switched to the prefix version. The rule here is the exact opposite. Increment first, then use the new value. And this just perfectly illustrates the difference. The variable A is first incremented to 6, and then that new updated value is used in the expression. Okay, let's move on to our final topic before we solve the main puzzle: the hidden traps of data types and automatic conversions.
Take a close look at these two scenarios. In the first one, we're dividing an integer by an integer. In the second, a float by an integer. This tiny difference in how the variables are declared leads to a completely different result. So why is that?
The answer lies in a mechanism called type promotion. See, C wants to avoid losing data. So before it performs a calculation, it promotes the smaller or less precise type to match the larger one.
In the first case, you're dividing an integer by an integer. This triggers what's called integer division, where the decimal part is just thrown away. 5 divided by 2 becomes just 2. The fractional part is lost long before it ever gets assigned to the float variable C.
But in the second case, because one of the numbers is already a float, the compiler promotes the integer b to a float as well. This means the operation is performed as floating point division, 5.0 divided by 2.0, which gives us the mathematically correct answer of 2.5. Okay, we've learned about associativity, truth values, and type rules. Now, armed with all this knowledge, let's go back to the very beginning and crack that code. The code isn't checking if 10 is mathematically between 5 and 20. Because of left-to-right associativity, it first evaluates 5 less than 10. Is that true? Yes! So that expression produces the integer value 1. The expression then becomes a new comparison. Is 1 less than 20? And yes, that's true as well. So the final result is 1. So to sum it all up, here's a quick cheat sheet for your next exam.
Remember the difference between postfix and prefix. Don't forget about logical short-circuiting, and watch out for that integer division trap. And hey, whenever you're in doubt, just use parentheses. Mastering these rules will really put you a step ahead.
Because mastering these rules isn't just about passing tests. It's about writing code that is predictable, reliable, and bug-free. It's about moving from being a person who writes code that works by chance to becoming someone who writes code that works by design.